I didn't realize I could do it from the chat.
That's cool.
I'll be,
We're just learning
50
scientific things.
years, I'll be out
They
there
know about
building my,
the system of
building my
biology.
stock. I don't think
Sure,
I
that's
would
gonna
be
get
wrong.
stuff with a pain in the neck sometimes, but. You're
Good.
good.
I have two daughters of mine this year, last summer, so I'm expecting them to.
Have you met Steve and Steve? I just want to connect you guys. Oh, she worked.
I ran into Frank at the Earth Day.
All right, we got everyone.
Right, yeah, he was still working. Did a good job on that. He was at Zell.
There's a couple
Passed
people
away.
that have them.
Yeah.
Beaver, yeah. Did you know him when he was?
I didn't know.
Yeah, he was at Noy, but when, as a student, apparently.
I didn't know. I wasn't there as a student.
Yeah, and then, he went to DC and he worked there for a while.
Yeah.
Yeah, but he was really, a big driver in Connecticut and Groton for adaptation. Frank has been.
Okay. All right, folks, we're gonna call to order here, in the meeting to order our May 20th, Wequetequock Clean Water Coalition meeting. So welcome, everyone, and I particularly want to welcome new members. Can you advance to the new members? I see a lot of familiar faces, but I know we at least have our guest speaker is new here. Jim, you want to introduce yourself real quickly?
Sure.
We'll go through a couple things and then introduce you or to
Want to
speak.
do it now or later?
Yeah, well, all right. Anyone else first time here, live in person? Hi. Could you introduce yourself to the group?
Hi, Brenda Rich. Into all kinds of conservation. I watch the ospreys right here.
Nice.
This nest is my assigned nest, and I've been watching ospreys for the state for 10 years. So,
Welcome, Brenda.
shorebirds, you know, the ones on the saltwater marshes, the low-lying nesters, all that stuff
Cool.
is of interest.
Well, it's great to have you. And, is this your first time attending?
Yeah.
Would you mind just saying hello towards the owl there? So the folks online can hear you?
I see, hi, Peter Fenn.
Oh, Peter. Paul,
Oh, Paul, sure. Recognize that.
welcome, Peter.
Yeah, Steve, filled me in on a few of the details as to what you guys are up to, so.
Awesome.
Yeah.
Well, welcome. Thanks for coming. Okay, and online, any first time attendees who would be willing to introduce themselves and say hello? No, no.
Oh. Melissa?
Can everyone hear me?
It's a little broken up.
How about now? Is that better?
Perfect, yeah.
Amazing. Hi, everyone. My name is Melissa DiFrancesco. I just joined the Nature Conservancy in Connecticut, and I am the new Watershed Conservation Coordinator. So I'm really excited to get to know everyone and see all the great conservation work that's going on in the state of Connecticut. So thank you.
Perfect. Thank you for joining us today. All righty. So for folks here in the room, just one housekeeping note. If you can project your voice towards the owl in the middle, it'll pick you up if you just sort of speak towards it. And that way, all the folks on Zoom will be able to hear you and know what's going on here. All righty. So today we're really fortunate to have a guest speaker, Jim O'Donnell. We had Jim scheduled this winter, and unfortunately, some things came up and he couldn't make it. But we think Jim's organization and his area of expertise is extremely relevant to what we're working on in the Wequetequock Clean Water Coalition. Because he's talking about resiliency and how to make sure that I believe systems can survive climate change and other things like that. We've already had pointed out in our wastewater work stream that essentially all of the septics along Wequetequock are very, very vulnerable to rising sea levels and at some point may face failure on that. So very relevant topic. So with that, let me introduce Jim. He's got some slides. Jim, if you do speak directly towards the owl, I think everyone will hear you fine remotely.
Okay. I have some slides. So yeah, my name is Jim O'Donnell. I'm professor of marine sciences at the University of Connecticut, and I'm the executive director of the Connecticut Institute for Resilience and Climate Adaptation. And that's Avery Point on the right there, and research vessel Connecticut, our flagship. I just like that picture. Next one, please. Okay, so these are probably familiar places to you, but and these are all flooding events, and I took these pictures over the last couple of years. The one on the bottom right, downtown Mystic in the Groton side. The one of the, and then the top right, sorry, bottom left is Groton, Mystic in the Groton side, and the top right is Mystic River Road. You know, and that flooding like that's now happened probably 4 or 5 times in the last 2 years. The one at the bottom in the middle is from Brantford, and that flooding is under an underpass under the railway bridge that carries the Amtrak line eastward. And then the one on the bottom right is in Guildford, and that's an ambulance on Route 146. So that was about 3 years ago, I think, that one. So these flooding events are not hurricane events. They're just sort of regular winter storms now, and I'm going to show you. I'm going to try to show you why those are more common, and why they're going to get more common. And then since I also think you guys are interested in how material moves in and out of the cove, I have a little analysis that will estimate how long things that go into the cove from septic fields and the streams stays there, and it's not long. Next one. Oh, so it's not just a coastal thing. This one in top right is Stamford. It's another bridge under the 95, and the one on the left is in Darien, Connecticut. So these are not coastal storm surge driven things. Those are precipitation driven things and bad drainage. So there's a combination of both. And in Groton, we have a location that goes under the underpass for the Amtrak line by the airport in Groton. And there, when it rains heavily and there's a storm surge, the pipe that collects the water under the bridge and drains it into the local cove gets backed up, and so you end up with a couple of potentially a foot of water in the road. The same thing happens down at the entry to Bluff Point State Park. You know, I was down there this year when there was about 1.5 feet of water under the bridge. Okay, next one. So, and this is part of the cause. On the top left here, I'm showing the locations in Connecticut and New York where water level has been measured for the last 50 or so years continuously, and they're obviously the big ports and harbors, and they've got a long record because they're important to navigational safety. And then the graph on the right shows the water level averaged by month at Montauk Point. So every little wiggle on the blue line is a monthly value of the mean sea level, and the red line is a average over 5 years, a running average through that. So it's, I would call it's filtered, right? It's smooth. And what you see is in about 47 or so when it starts, the mean water level was about minus 0.1 meter, minus 10 centimeters. And in 2016, when I made this, it was plus 10 centimeters. Right? So it's a 20 centimeter change in the water level in that time. So that's about maybe only that much, like a foot or so. Next one. So these are the same, a different perspective. It's a Google Earth view to the east, and you see the locations of the tide gauges again. And the wiggles on the bottom right there, they are the annual average water levels at Bridgeport, Willets Point, and New London. Willets Point is at the entrance to the East River, and they overlie each other. You can't really see any difference. So the whole sound is going up at the same rate. There's no slope in it or anything like that. And there's wiggles. So for a few decades, for a few years, it seems to be accelerating really fast, and then it decreases again, then accelerates again. And these wiggles are attributable to changes in circulation in the Atlantic. It's an interesting thing and they've been going on for a while. The yellow line is the projection for global mean sea level increase. That was, hey Charlie, you're late. The yellow line is the global mean sea level projection, and then the black line in the center is sort of extrapolation of the values through the Long Island Sound gauges, and so you can see that Long Island Sound is going up faster than the global average, and that's another the reason for that is well established, and it appears in all the numerical models that global circulation is because the Atlantic circulation is changing slowly. So next one. So I got assigned, drafted in like 2018 to make recommendations to the state as to what they should tell towns to do to accommodate this changing climate. If you're going to build a road or fix a bridge or permit new buildings, you should be planning for what mean sea level is going to be in the future, not what it was in the past. And all the stuff I showed you was from the past. The blue line there is from data. That's a prediction of the upper bound of what's plausible based on observations. So if you draw a line across the top of all those wiggles I showed you and projected that to 2100, you would get about 2 feet. There's a good chance that would be less than that. The best estimate would be like 1 foot. But if you just took a line through the old data and assumed it was going to continue the way it has been for the last century, it would get to about 2 feet, and that would be the upper bound of what's likely. And the orange and yellow lines, they're from global models that were results of millions of man hours of thousands of people with wide range of expertise trying to predict what's going to happen to the atmosphere and ocean. And all I did was extract from their simulations all of the predictions for around Connecticut, and they form an envelope, right? There's some are lower, some are higher. That the yellow line is the upper bound of all the projections, assuming that CO2 emissions are going to be capped in about 20 years, and then be constant after that. And that's kind of what the Paris Accord agreement was striving for. So the yellow line should be interpreted as being the upper bound of what the best science thinks is going to happen. The orange line is a quibble about that, and I don't want to go into that. But the purple line, which is the dramatic one with the 7 feet at 2100, that's a really pessimistic option, and it was included in the IPCC report as a way to try and estimate what the physically plausible upper bound might be. And so qualitatively, if you measure the rate at which glaciers are going into the ocean in Antarctica right now, and then look for the highest values, the ones that are moving fastest, and then apply that to all the glaciers in Greenland and Antarctica, and assume that they were all going to melt as fast as they could, that's what you would get by 2100. So that's very unlikely. The upper bound at 2100 of about 3 or 4 feet is more likely. And then maybe half of that is the best estimate. Now you can see that 2050, they kind of begin to diverge, right? The lines were all pretty close around 2010, 2020, then at 2050, they started to get wider. And so the planning threshold label there is at 50 centimeters or 20 inches at 2050. And notice that 50 centimeters is also roughly about 2 feet. So if you were to plan for 50 centimeters or 20 inches at 2050, that's a prudent thing. It's got a factor of safety in it because it's going to be likely to be higher than you might need. But at 2100, it's the lowest that you might need. So it's very unlikely that it would be less than 2 feet in 2100. So that's why the state has adopted that planning threshold and mandated it for projects which involve state or federal funding by municipalities in Connecticut. And many towns have adopted it as part of their zoning and permit stuff in the flood zone. Okay, next one. So I'm going to show you why 20 inches is a big deal, right? It's not, it doesn't seem like a lot. Let's just keep going at one more. Okay, first you have to know some physics. This is from the freshman classes I used to teach many years ago. And it tries to explain what tides are. So tidal fluctuations are not the water level, right? The water level fluctuations are partly due to tides. And the tides are formed because the liquid envelope around the Earth is spinning. And when things spin, there's a centrifugal force that causes them an acceleration to be outward from the axis of rotation. And then the reason that the water doesn't fly off is that there's gravity, right? And it's pointing towards the center of the Earth. So the center of the Earth, a force towards the center of the Earth can't balance a force directed normal to the axis of rotation. And so the ocean is forms in a oblate spheroid, and that's an elliptical shape there. Right? And that's basically an equilibrium. There's a bulge towards the moon as well. And so it's elliptical, and then there's a bulge towards the moon because the moon's got gravity too, and another one towards the sun. And the solid Earth sort of rotates relative to that a little bit. And so now those frequencies at which the Earth rotates through those bulges are prescribed by astronomy, right? We know exactly what the rotation rate of the Earth is and what the rotation rate of the moon around the Earth is and the Earth around the sun. Very precise. And what those cause is periodic oscillations in the water level. And you can predict them for years at a time. Next one. Sometimes the Earth and the moon and the sun line up, right? So they're the bulge created by the gravity of the Earth, of the moon, and the sun are in the same direction. That's the top figure, and the bottom figure, the moon is to the top, right? So then the moon and the Earth bulges are not adding up, and that's what causes the spring loop cycle. Next one. So I show you that because the blue line there is the prediction. In the top figure, the blue line is a prediction of the water level fluctuations due to the tide at New London. And the green line is the water level fluctuations that were measured in, I think that's January this year. When I made that. And the axis on yeah, it's about a couple of feet, you know, and then but the big green peak there on the left, that was a storm. So the difference between the green and the blue is due to the weather, and that's kind of the unpredictable part. We can predict weather maybe 2 or 3 days out, and we can actually do quite a good job of forecasting how high those peaks are going to be a day or two ahead. But we don't know next week what the weather's going to be, right? So we don't know really how the weather is going to change in the future. The models that I showed you the results of about climate change that predict warming, etc., they're good at, we think, predicting the monthly average maybe, but not the weather. So the best we can do is use experience that we have from data in the past. I'm going to show you what that means in a minute. So this bottom line figure is the difference between the blue and the green, right, for the last 80 years at New London. And the left axis is in feet. And you can see there's lots of peaks, and the biggest peak there on the left, like in the mid-50s, you know, that's a big hurricane, I forgot its name. And then the big, yeah, and that's it, yeah. That's before I was born.
Me too.
Okay. The one on the right there, the peak is Superstorm Sandy, it's 2012. So the way to look at, and then there's lots of other storms around there, right? The way to look at this is that, and this is a simple thing I want to illustrate. if you were getting flooded when the storm surge was 4 feet, right, you should expect to have been flooded 5 times in the last 80 years, right? So if things stayed the same, you should expect to get flooded maybe 5 over 80 times in the future. And if you then ask, well, what would the effect of a mean sea level change be? If all the weather was the same, right, and the mean sea level had been 20 inches higher for the last 100 years, the data would just be look like that, except it would be 20 inches higher. And if you do that, press the button, it'll show you what it looks like, right? And so there, I just did it, right? So now all the number of times that the water got above 4 feet goes from 5 in 80 years to 48 in 80 years, right? So your risk of flooding or your expected flooding frequency would go up by a factor of 10. That's what 20 inches do. Right? It increases the risk of flooding by a factor of 20. Sorry, a factor of 10 for a 20-inch mean sea level rise. Now that's the upper bound of what's likely by 2050. And it's a lower bound of what's likely by 2100. So it's fairly plausible sometime in the future. Now, if your insurance rates were linked to the risk, you'd expect them to go up by a factor of 10, right? Or if the damage to your property or the repairs to your septic field, whatever, right? You should expect a factor of 10 increase in that for a 20-inch sea level rise. Next one. So this is another way of this is a pretty important graphic. This is the same data, right? And there I plot on the horizontal axis 1 over the risk. So that big black diamond in the top right, that's the estimate of the water level at New London during the hurricane of 38. And this axis on the left is NAVD 88. And then the second one, the red diamond that's labeled there, is Superstorm Sandy. So the way this graph is created is the record length is nearly 100 years, right? And so that value of maybe 2.6 or 7 meters has been reached or exceeded once in 100 years. So its return interval is at 1 in 100, right? So it goes on the log scale here on the horizontal axis at 100. Sandy has been reached or exceeded twice in 100 years, so it goes at 50, right? Then the third one is been reached or exceeded 3 times in 100 years, so its risk is 3 in 100, and 1 over that is 30, right? So you order these peaks, and then you make a graph like this, and what you see is it follows a line pretty much. And there's a good statistical reason for that. And I'll save you the mathematics, and then you fit a curve to it, and then you can extrapolate that curve to estimate what the 200-year return interval was. So that would say what's elevation you would expect to see sometime in the next 200 years, the biggest elevation you'd expect to see. And FEMA do this to create a 100-year flood zone. That's how they do it, and their numbers are the blue line there at the top, and there's a little hexagon with that blue gets filled in blue. From their reports, I could only extract those 3 points. And those are, I was trying to replicate what they did to understand what the implications of some assumptions would be. Because my estimate's a little lower, right? But you can see there's lots of scatter, especially at the long return intervals. And so it does make a lot of sense to me to argue whether the 100-year flood value is 2.5 or 2.6. It's not, or if you draw it on a map, you see a line in the map, right? But typically the line in the map is like a narrow thing. And if the land is fairly flat, then being on one side of the line and the other side doesn't really make much difference to your risk when you see what the uncertainty in the risk calculation is. So that's an important thing. But down at around 1 in 10, right, the 10-year return interval, all the points line up in the line down there. There's we've experienced lots of those. And so the confidence in our estimates of what the 1 in 10 storm or the 1 in 20 and 1 in 30-year storms is pretty high. The next one. So again, just to make this point a little clearer, So down here, like I could tell you now that the risk of the elevation that should be expected once every 10 years, a 1 in 10 risk in any 1 year, is about 1.4 in London, right? Now, next one, and if you add 25 centimeters to that, right, to the mean level, again, please, look at maybe twice, right? Sorry, back one. That line would be this blue line now, and so it moves the risk from 1 in 10 to 1 in 2, right? So, and that's very high, there's high confidence in that. So if you knew what the future sea level was going to be, you could predict the change in risk really well, and maybe make some money on betting on insurance deals. Next one. So what does it mean for Wequetequock Cove? So this is a little map I made, and these yellow pins are where I put out some instruments. Well, not me, my team. Sorry, we put out some instruments, and I'll show you data from those to measure water level. Because the first question I wanted to know is, does that bridge abutment restrict the flow into the cove sufficiently to provide any flood protection? Because if you close that off, right, then the water wouldn't get in, and it wouldn't go up and down in the basin. So you open up, you get some flow through it, and the question is there any restriction? Then these colored lines are contour levels in meters. So the blue line on the water is -1 meter. The red line is +1 meter. Is relative to NEVD 88. And then the blue and yellow, the cyan and yellow are 2 and 3 meters. And I'm going to show you some more of that. And the red, so you can see the saltwater acre thing. Sorry?
Jim, could you repeat those again?
So red is 1 +
Yeah.
1. The cyan is
Meter.
meters. Yeah.
Yeah.
Meters. Yeah. That's like 2 and a bit, 3 and a bit feet. All right. So red goes around saltwater acres and vineyard there. So that's red. So that's +1. Right, so that's above NEVD 88, which is roughly the mean high 1, I think. Okay, next one. Okay.
And that water coming in is coming in just through the bridge.
So it doesn't take into
Because
account.
a lot of our events lately
or
been a
rainfall.
combination
Oh,
inland flooding.
yeah, I can show you that. Well, I don't remember if I included this graphic or not, but I'll tell you about it in a minute. Okay, so let's go to the next one. That's just a map, a different map. Oh, so let's go back one. You can see what the water depth is in this chart. There's not a lot, there's only a few soundings there, and it's feet below mean low water. So it's pretty shallow there, but there's fortunately a better product. You go to the next one. This is just some of the, you may have seen them out in the cove in March. These are instruments that measure the salinity of the water, temperature, and the pressure. And then from that, I can tell how much the water is going up and down, and how much of it is fresh and how much of it is from the ocean.
How long have you collected this data on Wequetequock?
That's the entire record. It's about 3 weeks.
Okay.
Yeah, this is for free, so.
Yeah. Just one thing of note is the Fish and Wildlife Service is assisting with one of our work streams to convince Amtrak to help us improve tidal flush under the thought that would
Okay,
clean the
well,
cove out. And the Fish and Wildlife Service is planning to put like some gauges in to gauge what there's an. I'll have to look at my email to get the name of them. I don't know what they're called, but they're planning on installing like 3 of them.
so yes,
For salinity, like to see
Yes.
what's back flowing in type of thing.
I think it was like depth and flush, but I'll double check.
I'll show you what, anyway, so let me make my point, and I'll show you salinity. Okay, so the top there is actually the water level at both those gauges, right? And you just can't tell it's different in the top one. So I blew up the section between the 2 vertical dashed lines in the top one, right? And so that's between March 25th and March 27th. And you can see the red and the blue. So the red one is south of the railway bridge and blue is north. And so you see there's a very slight time lag between the time of high water just offshore, and it's very small. And then this bottom line is just the difference between those two things. So most of that difference is temporary. It's just that the water level inside the cove is coming up a little bit after the high water outside. So it's not rocket science then. But I did a little mathematics to calculate, what causes that, and it's for the model that I did is similar to what these guys are probably going to do to assess the impact of the bridge abutments. Okay, next one. That's the same thing. Oh, no, this is important. So the red and blue are the two from Wequetequock Cove, and the black is from New London. So like, the question here is the data from New London relevant to Wequetequock Cove? And the answer is unfortunately yes, right? So the water level inside the cove is basically following that outside the cove, which is following New London gauge. So within centimeters, it's just a little delayed, maybe like 15 minutes. So the tide sort of propagates here first, and then it reaches New London. So we're a little bit ahead of New London. Okay, so all those things I showed you about New London apply to Wequetequock Cove, and the tide and I don't think the presence of the railway bridge abutment does anything for flood protection. Okay,
So it doesn't do anything for flood protection.
right. Okay, but well, yeah, I think by centimeters, but just delays it by by a few minutes. That's all. So any surge.
Sorry, I did find what they're asking for. They're asking for, where is it? Sorry, water level logger,
Okay,
because they're gonna put in, and they're generally asking about these are all new things to be, but bathymetry.
oh, yeah, that's actually valuable. Let me show you the next slide now. I'll show you one. So, well, you guys know this area better than me. I just did it, so I knew what I was talking about. So there's two major streams come into this, and I forgot what the area is. It's maybe like a little less than a square kilometer, maybe 2 square kilometers, something like that. Next one, and all that's the whole watershed. Now, so this thing on the right is a website that NOAA and the USGS maintain. It contains LIDAR, and they call it the Integrated Bathy Topography and LIDAR product. And basically, the state of Connecticut contributed data to it, and they fly airplanes over Connecticut in 2016. And they've got lasers on them and sophisticated navigation systems, so they know exactly how high the airplane is and what direction the beams are pointing. And they scan the distance to the ground. And they do it in the fall when there's very few leaves around. And so this colors on the left here are the elevation. And there should have been a little key for the colors, but the yellow is about 3 meters or so. And then I've got a bunch of contours on there too. And I excised this because I was trying to calculate the volume and surface area of the water in the cove. And so, because if it's like a bucket, right, that's the size of the bucket. And the water comes through the cove, through the bridge abutment into the bucket, and it goes back out sometimes. And the rate at which that happens is proportional to the difference in water level inside and outside. Right? And then there's also a stream flow from these rivers that goes into it. So all the water coming in ends up going out, right? Averaged over a month or so. And so you can write an equation which describes that rate of change. And then the rate of which it goes through the bridge depends upon the cross-sectional area of the bridge, the depth, and a thing called the Manning's coefficient. So you can estimate those things from data, and I've done that. It's a exercise I have for students in one of my classes, so it wasn't that difficult. Getting the data was just awkward. Next one.
So what percentage of the water at high tide did leave the cove?
I'm going to reveal that. I'm going to reveal that in a moment. Okay, so this is actually about topography again. I just want to be clear about what where. So if you own some property here, this you'll see what the water level is. So this is the green line is a +1 meter elevation again, right? So next one. The red line is a plus. This red line is actually Superstorm Sandy. That was, if you take the water level at New London and you project that onto this topography, that is the extent that we think water got during Superstorm Sandy.
Pretty accurate.
Yeah.
Going across the road.
Yeah, I've done this other places, and the USGS they went around a week or so after Sandy with a GPS system and an altitude sensor. And they looked for water marks on roads and on bridges and grasses, and they measured the elevation of that debris line. And they collated it with predictions like this in some other places we've done it. And so it's pretty good. And then next one. So, and this one is the hurricane of 38. Now, so notice it's not much different from the red line. And that's a kind of curious thing. It's true across Connecticut too. And if you add, like, if you were to add 20 inches to that mean water level and draw another one, if you drew the line which you think was at the altitude Sandy or the hurricane of 38 was plus 20 inches, which is what a hurricane like that might be in 2100 or 2050. It doesn't look like much different either, right? And the reason it is sort of interesting that much of this topography was sculpted by glaciers. And 10,000 years ago, Long Island Sound was dammed by a moraine that went from the North Fork over to Watch Hill. And Long Island Sound was actually fresh. And south of Long Island Sound, south of Long Island, there was land. I mean, it was dry out to a continental shelf. And there was a river went out of this lake and ran across the shelf through Block Island Sound into the ocean at that time. And then during that time, glaciers began to melt, and they carried the sediment that they had excavated from Vermont, New Hampshire, down these streams, and they deposited it in the lakes. And so the lakes developed deltas around the mouths of all the big valleys like this one. Right? And these deltas were sand and gravel, and they were kind of flat. And so then when the lake was broached by rising sea levels, the lake drained and the water level fell, and these delta surfaces were exposed. And so those areas were about 1.5 meters above current mean sea levels. Those delta surfaces are left. And that's when people came to colonize the United States, right? They built lots of the property and all the development in New Haven and Brantford and Milford on these relic delta surfaces. And much of what's in this valley here is relic delta. And it's covered by marsh, much of it, but it's sand and gravel below the marsh problem. Anyway, at the edges of these sand and gravel, it's steep. Right? So the flat bit is typically where we're getting flooded now, and increasing mean sea level doesn't increase the area that gets flooded very much. It just increases the frequency at which that area gets flooded. And that's why these lines are kind of close together, the Sandy and the hurricane of 38 lines. And then if you add mean sea level changes, they don't get much further apart because it's typically pretty steep around these kind of outcrops of rock. Okay, next one. And you can sort of see that this is if you plot the area of that polygon I drew on the map, I calculated how much area was between different elevations, right? So the vertical axis is the elevation, and then the horizontal axis is the area that is within a 0.5 meter bin around that elevation. You can sort of see a flat bit there just above sea level, right? So it's kind of steep there up until 0, and then it goes flat, and then it gets steep again, right? That flat bit is where all the parts that get flooded just now, right? Then if the water level gets higher than that, it starts encountering a steep elevation increase and doesn't get much further. And then you can see, okay, let's skip to that next one. So this is the bottom figure here. So if I know the shape of the bowl, right, which is what that graph showed you, it's how wide the basin is for different water depths, and I calculate how much goes into the bucket, I can tell how high the bucket's going to be. So with the measurements of the water level in the cove I took, and the data in that graph that I made of the variation in the cross-sectional area with elevation, I can calculate how much water is actually in the cove during that period where I have the measurements. And so that volume is cubic meters times 10 to the 5. So an average of all of those blue lines at the bottom would be about 2 or 3 times 10 to the 5 cubic meters. That's how much the average volume is. But you can see that there are times when it's maybe twice that, when the water level's high, and there's times when it's like half of that. And each tidal cycle, so if the mean is about 2, right, roughly about half during the lowest tides, when the water level is at its lowest, about half the water leaves the basin on each tidal cycle. So half it empties out and half it comes back. During these times when the water level is high, it looks like even more of it does, right? It's like you point to it. It's hard to so here, this time here, there's probably, yeah, if the average is here, there's roughly 2 or 3 times as much water in the cove here than there's normal. And then 6 hours later, more than half of it is gone. So roughly, it's a good thing, a good estimate is that on each tidal cycle, half of the volume leaves and is replaced by an equal volume on the flood. Okay. So, and then let me show you salinity, which is next, I think. So this is the red bar here is the time period where we had the instruments, and this data is precipitation. The bars are in millimeters per day. So 24 millimeters or 26 millimeters is about an inch, right? So those 3 big things, 3 big blue things within the red band, those are about inch per day events. And the air temperature just was to show that it's cold when we did it. That's why I didn't go. Next one. Now, okay, so here are this top figure is the measurements of the salinity sensor, right? The salinity is the concentration of ocean water in the cove, basically. So you can see the blue line is a sensor that's in the Mystic River, and the red line is the one that's north of the railway bridge. So you can see the red line. Give me a point again. So this line here is down to 10. That's 10. It's parts per thousand. So if it was pure Mystic River water, it would be about 25 or 26 parts per thousand. What you see is that during the periods after the rain, so you can see here's a rain event like on the 23rd or something like that, major rain. Then after that, you see the salinity drop off from being, the red line is initially about 24, so it's mostly Mystic River water.
You mean Mystic or Anguilla?
Well, whatever is to the south, whatever you call it, right?
Okay, this is still the cove.
Still, well, yeah. I mean,
Okay.
The cove. I got asked one time by Killington people, is Fisher's Island Sound part of Long Island Sound? But some laws apply to Long Island Sound, which won't apply to Fisher's Island Sound. So where the boundary is a detail. But basically, the blue is what's south of the railway tracks, and the red is what's north of the railway tracks. And during on this day, you see they're both almost the same, about 24 to 25. Then there's a rain event that causes the salinity in both to go down, but the salinity north of the railway tracks goes down much further. And so at that point, it dropped only 20% of the water in the cove came from the Mystic River. All the rest came from the stream, right? So this red line essentially is a fraction, the fraction of the water in the cove that came from the Mystic
Oh, you
River.
mean the Pawcatuck River?
So did I say Mystic River?
Yeah.
Sorry, that's, yeah. Fisher's, Little Narragansett Bay.
Yes.
Yeah, sorry. Yeah, my credibility is not short.
But we understand.
It's all connected.
Yeah,
Yeah.
so my point though, and then notice after that, right, after this rain event, the minimum value in this quantity increases. Right, but the thing of that is like it's getting, stirred and flushed, right? So you bring in some fresh water and it's all fresh. You bring in half of it salt water, you mix it up, and then half of that comes back out. So then some of what came in is freshened, and when it goes out, it's essentially the mix, exported fresh water doing that. And it takes a few of those, right, for it to become back, to get back up to being the same. So this is 586. So roughly from this rainfall event here to that period, it takes about 5 days. And there's like some mathematics I can do to show you why it's 5 days. You know. And then you see the same thing happen again. There's like another rainfall event here. And a slower one after that. That causes the Mystic River, the Wequetequock Cove salinity to drop relative to the Little Narragansett Bay. And it's a little more complicated here, but it does increase again. And then then there's another one here where it's low and it increases again over a period of 3 to 5 days. So that is you know, the simple interpretation of these measurements. And I think what's one more minute? Yeah, sorry. So this is like the points I think you thought you might be interested in. One is the flooding statistics are the same as in New London, right? And so if you want to understand how things are going to change, there's good measurements for that. Superstorm Sand should be expected at about 10-year intervals in the future. Looking backwards, the estimate was about 30 or 40. It's like a 1 in 30 or 40 event. And it's going to, but mean sea level increases by 20 inches in the next 50 years. That should be expected to be roughly 10 times more frequent. And the consequence of that is pretty straightforward. It's going to impact property, insurance rates, and septic field operations. And these smaller storms are going to occur more frequently too. The good news is that flushing in the cove is really high, right? That a minimum half the volume exchanges on each tidal cycle. And so, and the reason, let's go back one for a moment. Yeah, so the reason I point that out is that if you wanted to sample, if you want to understand how nitrate levels were changing in the cove, or how bacteria levels were changing in the cove, it would make no sense just to sample like once a day, right? Because the fluctuation in the concentration in salt there looks like it changes by maybe several 100% of the mean, right? In 6 hours. So that and where you sample and when you sample is going to be very, very what you get is going to be very sensitive to when and where you sample. It's not like once a month it's going to tell you anything here, right? Or even twice a month. You got to sample maybe a couple of times a day or year. So it's a famous physics result called the Nyquist theorem. It says that if you want to resolve the fluctuations of a particular frequency, you've got to sample at least twice that frequency. And now doing that with bacteria is difficult. We have instruments that can measure nitrate that are similar to, similar in size and expense to those instruments like pictures I showed you. Like $25,000 each. And but they could sample fast. The bacteria, you really can't, but I think you have to be smart about it then. You have to know what the salinity is, you need to know what the tidal phase is in order to interpret those results properly. So any questions? Okay, I'm out of here.
So, Jim, one of the thoughts that has been circulated around this group and others was that if the flushing were higher, the code would be less impaired. What are you, given that the flushing rate seems very high? So, you know, the idea is like to enlarge the train bridge, right, to allow for
Yeah.
more flushing. Is that a worthwhile pursuit, or do these
No.
observations argue that that's a worthwhile pursuit?
But I spent like an hour a day trying to figure out, you know, what the impact of the width of the bridge is. And and my conclusion was that, you know, in order to make it important, I have to narrow it a lot. If I narrow it in my model, if I narrow it a lot, I can make it important, but if I widen it, it makes no difference.
Can you go to the map that you showed overhead? Because yeah, we do have a hypothesis that it doesn't flush enough. And we don't have any data behind it, just kind of
Yeah.
a common sense approach to things. But I've measured using Google Maps, the causeway there.
Yeah.
And from what you might, if you just took a natural shoreline, and it's a 93% closure over what would have been the natural shoreline. Now, of course, there's depths that impact that, so it's probably not totally a 93%. And you know, we're looking for reasons like, why does this cove stand out? Why is it so much dirtier than the Wequetequock River, Stonington Harbor, BB Cove? You know, and it does seem that it has you know, less flushing ability.
Yeah, well, I thought the same thing. Yeah, and I went down at Saltwater Acres last weekend, and I took a picture because I measured the width of that gap using Google Earth. And
These are the same thing.
yeah, it's not very, and I got about 25 or 30 meters wide. And the water depth, the soundings are not great, and LiDAR doesn't work under the bridge. So I'm guessing it's about a meter and a half deep there. But how deep is it?
Very deep. It's about, what you said, 12, 15 feet.
Yeah.
All the way up.
No, just at the, just,
So if you average from the southwest to the northeast side of the bridge, what's the average depth, you think?
oh. I mean, you have that one
Well-
spike in the channel, but normally, I mean, you can stick a oar or a pole
Yeah.
down, and
So I was thinking it would average out to be about a meter or so. Anyway,
I think that's probably right, yeah.
yeah. So anyway, if you made it deeper, it would increase flushing, right? And so my estimate is kind of conservative, and I just don't see that it's a substantial restriction. Now, and you can see from the data, right, that the salinity is now. Yeah, I'm confident that the volume calculations are right. That at least half the water leaves on each tidal cycle.
That makes sense.
And I haven't finished the calculations with this salinity. So it might be that that there's well, no, I think if you look back at the salinity data, it takes 3 to 5 days for that peak, right? So it's like a freshwater peak that pushes the salinity low. Then after 3 or 5 days, it goes back to being high again, right? That's a measure of that's the best measure of a flushing rate. It takes like, if you had a pulse of bacteria in there, it would take 3 to 5 days to get rid of it, right? Or a pulse of nitrate, that would take 3 to 5 days. And maybe widening the channel would change that. And I haven't concluded that yet, but
Yeah, I mean,
What about the, so basically you're saying the volume rate is pretty good, but what if widening it, like eliminating dams, would you change the biology and improving the biology perhaps? would you create a different environment and different healthier habitat?
Yeah,
And that would change your nitrogen and everything.
yeah, I couldn't, measure that.
But I mean, like when you, I mean, kind of like the whole something being damned.
Yeah, well, so that, but the thing is that when you, when you make it narrower, the water just goes through that gap faster. Right? Until you get to a point where it's so narrow that the water can't go through enough. And in Guilford Harbor, if you've been over there, you see that there's like a huge setup. I mean, like on the ebb, the water's going out of that cove at like 3 meters a second. And you can see the slope in it. The water level in the cove is higher. And it's so fast that it's hard to measure, but my team went over and did it. And so there, the constriction at the mouth of that is substantial, and you can see what it does. Now, this gap, and I did the same thing in the Mystic, actually, a few months ago. The gap, there's a restriction due to the Route 1 bridge in the Mystic River. And I was wondering whether that makes a difference to the water levels up around the seaport. We've got a project to try and assess the vulnerability of the seaport area to flooding. And it doesn't. So the water's just, it's wide enough that the water can get through, and the enhanced friction associated with going really fast is not enough to make a big difference. So at the moment, I don't think there's strong evidence. Yeah, but I'd hedge until like
Can we go to the one where you've got, where the sensors were?
Yeah.
Because the one thing that it's striking me is it looked like it wasn't that far outside of the bridge. So it's not, right? It's not even the Goat Island. So that's where, when you were measuring salinity, is that the point south?
Yep, and there was a big difference, right?
Yeah, right. So what you are picking up actually is a big difference that takes 5 days to normalize.
Yep.
Right? And so at some point, there was no causeway there, and presumably those things would have been actually very close to each other without the causeway, because that's the only real difference.
So you can see that the water levels between those two places were always very close to the line, centimeters difference. So if you were to close that gap, right, then the water levels would be radically different. And once you begin to open it up, then the difference between the two water levels is going to get smaller and smaller, right? And maybe, there's a more careful analysis that could be done to assess the flushing
Yeah. I mean,
more carefully. But the first cut, right? Half the water that's coming and going, and if you half it, and take out the mixture and half it again and take out the mixture, it doesn't take very many of those to get it back down to a difference of 10 or 20%. So it gets to if it's sort of an exponential thing, right? The difference will start from here and it'll go exponentially. So you have to wait a long time to get it back to zero, but it'll fall to half the value in probably a day and a day. And if you go back to the salinity diagram, we can see that, I think, in that first big pulse.
And the water testing was done at the same.
Am I going
Yeah.
the right way?
No.
Yeah, they're both near the bottom, like about
But one thing about the cove, Jim, is that where you were. So you've got half the volume in, half the volume out, but if you go, say, where the Stonington Marina is, right? So the cove gets fresher as you move up into the cove. So I think the resonance time of the water changes as you move up the cove, right?
that's plausible. Yeah.
That the water at where the Stonington Marina has been sitting there a lot longer and is getting flushed way less than the water that's the entry and exit of the cove, right?
It
So,
takes 7 or 8 days to clear it out instead of 5.
yeah, something like that. Like, so,
Yeah,
this is a whole cove average, and then within the cove, there's slices that flush out a lot, and then slices when you go up the cove that flush out almost not much, right?
So yeah, that's certainly plausible, but I doubt that it could be. like a factor of 2, right? It's very unlikely, in my opinion, that you could detect. I mean, the way to do that would be to put 3, salinity sensors up there,
Yeah.
right? One at the closed end, one.
I think we have those data from Cush actually, because they have 2 stations within the inside of the bridge. They have one where near Paul at the Stonington Marina, and then they have one probably more where you are.
Did they have one outside?
And they have one outside.
Yeah, so I could look at that, man. I think you sent it to me, but there was some reason it wasn't adequate. That's why I put these out.
Yeah, they would, I mean, it's every 2 weeks.
Oh, they have a one measurement every 2 weeks.
Yeah,
Oh, that doesn't help.
yeah.
That's why you need to resolve,
Yeah.
like, you need to know the Nyquist frequency, right?
Yeah.
Which
yeah.
is like,
Large sampling rate.
yeah, it's like, the highest tidal frequency is 12 hours.
But then one thing that I would surmise is that if you widen the bridge, it might not change the flushing frequency of, say, up the river, up the cove by very much. Like say this hypothesis is correct, that where Paul is, it doesn't flush much because it's like in the little narrows. But even if you widen the bridge and say that it probably wouldn't change that dynamic very much, right?
Well, I mean, I'm happy to look at the salinity a little bit more and try and assess quantitatively that, but you can see there from the 25th, right? It gets back to half the difference goes back to like half the value within a day or 2,
Yeah,
right? And in another day or 2, it's back to normal, right? And I think that's like from just looking at graphics,
yeah,
that's the best you could do.
yeah.
And so maybe further up the estuary. Now, there is one thing that I might be goofing on here, and that's that I didn't realize that the freshwater concentration was going to be so high. So there could be a significant stratification here, but still, that's the bottom salinity,
Yeah,
right?
Yeah.
It's hard to be fresher than 5. Right? The freshest water is 0, right? In the Connecticut River, in the spring, when it's pushing 2,000 cubic meters a second down the river, is fresh at the surface. But that's like one of the few places in New England where it's not fresh. This is unusually fresh.
there's a lot of.
I think
Yeah.
as a group, we have to be ready to let go of things if they're disproven. So this is really interesting. It's been just that common sense, like, oh, this objectively looks to flush less than other things like it. So what areas would you look for suspects in? What would?
Well, the biggest unknown seems to me that, well, in terms of identifying the problem, right? That from a circulation and mixing point of view, I'd like to know what the river discharge was, right? I know what the precipitation was. I know what the watershed area is, and so I can estimate how much fresh water eventually gets into the cove, right? But I don't know how fast it gets there. And so water level measurements of the stream flow at a few places for a few months would help. And that may also help address this issue of how quickly flushing occurs in near the up in the streams and up in the northeastern part of the cove. That's one thing I think would be additional information that may help you. But the problem is too much nitrogen, right? Then in the summer, right? Then it may be that the investment of money is better, in reducing the nitrogen load rather than trying to increase the flushing.
What about sediment accumulation too? Like dredging might be a possibility. There's Sandy Point that kind of blocks off a little bit.
Well, I think that yeah. So many of these little coves, yeah, your guess, like the constriction is causing sedimentation. It's got lots of plausibility, right? Sediment's not the same as salt though, or it's not dissolved substance, it sinks.
Yeah.
Right, and so I think it's plausible that many of the coves where this kind of construction across the mouth has occurred have sedimented. Though geologists actually that it's not measurable. Like you can do cores through these things and you don't see an increase in sedimentation.
So things we have observed that, and I think all the folks who are on the co-op would agree, is that, there's animal life has decreased. For example, oysters are gone,
Yeah.
scallops are gone. So there's been an impact on animal life. There's been an impact on plant life, like eelgrass is gone. We also can see, just if you use a boat there regularly, that it is more shallow. And that seems to be the sedimentation, and the mud has gotten deeper decade after decade after decade. So, you know, is it plausible like that the sediment might have killed the oysters and
Yeah.
made it difficult for them to thrive, or?
It's clearly,
Um,
it's clearly DO is low, right?
Mhm.
And your data shows
Yeah,
that
so the sediment too is mostly organic material. So there's two things. It's like a self-propagating,
Yeah.
no decomposition of all the stuff that comes in
Yeah.
from the land, right? Because there's no oxygen. So, yeah, so the sediment, I don't know what it was like, but I would assume it was more sandy when you were younger.
People like, no, actually, I swam in there, you could feel it with your feet.
Yeah.
There was sand at the bottom.
And now it's
People talk
just
about that.
literally black organic
Yeah.
muck, right, which is so. Yeah, it's self-propagating. The more of that muck you get, the more it feeds itself, right?
so, and is that coming down the streams, you think?
Well, I think it's all the organic material.
Oh, it's organic?
Yeah, it does not decompose because there's
And-
not enough
And
oxygen.
there's a couple
Yeah.
loops that seem to be happening again. This is where pointing us in the right direction. One is, it just happened like in the last 2 weeks. The water went from the end of the dock. I could see right down to the bottom, was clear, right? Within the last 2 weeks, it was like someone flipped a switch. It starts to get like a green tinge. And then, all this seaweed starts to form, and then it floats to the top. Then eventually it sinks and it forms a mat that like you can almost peel off the
Yeah.
bottom. And then the geese like contribute a ton of fecal matter.
Or do they just eat what's in the cove and reship it out? So
Yeah.
It's a closed circle.
Could be. Well, they go up on shore.
Yeah.
They go into the fields, they graze, and then
Yeah.
they,
So one thing that I'm learning from this graph is that the contribution from the freshwater from the land is huge.
Mhm.
So it reinforces this sort of notion that I've had that what people put on their lawns, what's in their septic tank, whatever things
Nutrient control.
goes right into the cove, and that is a bigger problem than it's even bigger than I surmised, because I didn't realize how much fresh water comes into that cove.
Yeah.
And the fresh water is what carries everybody's waste.
Yes,
But this is in the freaking rainy period that we have, it was so
Yeah.
awful this spring. If you go in August, the water barely comes out of Anguilla.
Yeah,
And I'm just curious what that would look like.
I think that's probably, I think that's pretty much, you know, you see there's probably, there's not much storage in that water. So once it rains, it's probably it's over within a week. And that's one thing I think would be good to know, like how long typically when you measure the stream flow in a river, you know, there's a peak of rain when the rain stops, and then it sort of ramps back down again. And it's called a hydrograph, and there's a parameter you can measure. Some basins are very steep. Like if it's a small basin with not much soil and a lot of impervious cover, the water scoots off the surface of the land into the streams really quickly. And that's sort of an unhealthy situation.
And that's when everybody fertilizes when it's pouring.
yeah.
So,
Best practice.
yeah, so
That's, yeah,
So
and every
what-
bud
what-
filler and.
What I'm hearing is that we should have a critical eye towards the flushing hypothesis. There seems to be good reason to think more about the introduction of things like nitrogen.
Yeah.
And we did hear from the Anguilla Brook study, number one, they thought was runoff, number two, failing cesspools and septics, which we know exist. But it also makes me wonder, like, if we could explore some other things, because the way the shellfish disappeared, is the other stuff that goes in with the fertilizers. So for example, the pre-emergent, stuff,
Mhm.
those are deadly for shellfish.
The pesticides
Yeah, yeah.
That are killing off yours.
So,
It can grow.
so I know that insecticides kill lobsters pretty well. In fact, insecticides kill a lot of stuff.
Yeah.
And but those those concentrations are hard to measure, right? Like one part per billion, I think, is a number of, or 2 parts per billion would kill lobsters.
And then with the shellfish, what I'm really thinking of is preying.
Yes.
And preying in a broadcast setting to control crabgrass. Where there are some, that could.
So like sampling for that should appreciate like this data, right? Then if you want to know what the concentration of these the contaminants are, you should try and sample it just after a rain event, right? And then maybe for a few days after that in the cove. That would help diagnose what the problem is. I mean, what you don't want to do is invest a lot of time and money and then not have any impact. So I think that your point about dredging, it's probably cheaper than rebuilding a bridge, right? But it's more expensive probably than nutrient controls at the source.
It's permitting.
Well, the nutrient control at the source would be the town sewer. And according to them, that's very expensive.
Oh, yeah, well, yeah, but fixing septic fields is generally like hundreds of dollars, to the extent that, because a lot of people just don't maintain them.
Yeah, well, a lot of these are cesspools. There's not, yeah, so there's no maintenance of that, right?
And
Just-
there's no nitrogen removal normally from
Yeah.
a septic field. That problem with that is
Yeah,
the nitrogen is going in, and when they fail, you get more nitrogen and you get bacteria.
yeah.
Well,
So
we have we're seeing that.
Yeah, well, can I add, as an osprey watcher, osprey lover all my life, when we only had about 1,000 left because of DDT in Connecticut. Big osprey watcher. I've been watching this nest for 10 years as my assigned nest, but I've been watching them all my life. There's been a little bit of concern on the Connecticut River with a few nests. And it's been kind of like, why are they not producing eggs? Why are they not producing young? And I feel the next DDT is already here somewhere, but we just haven't figured it out yet. It's doing something to their reproductive system. We're doing great. We got 1,000 nests. We had 850 new osprey born and fledged in Connecticut. Fledge. We only count them when they fledge. This nest out here, for the first time in the last 2 years, hasn't produced babies. And like I said, this has been my nest I've watched for 13 years. And I follow a lot of rehabbers. I've done some basic training in rehabbing. I see some of our best raptor rehabbers. Now they're getting birds with they always look for rodenticide and they always look for lead poisoning. But now it's like, why is this bird poisoned with zinc and mercury on the Connecticut River? And it's like, is it coming off the bridges? What is and that's just happened on the Connecticut River in the last couple of years. They've been getting some birds in. So, the osprey has always been considered very important because they're a sentinel species on the health of our water. And, as our bunker come and go.
Dam removals. Dam removals can resuspend a lot of the contaminants from yonder.
But you have rehabbers scratching their heads going, why has this bird got mercury and lead poisoning? That's measurable. So,
go ahead, John.
Jim, I guess this seems like a really narrow set of data points. Would you and your modeling expect something to be different if it was done in August? Did the amount of rain affect your flush rate?
Yeah, well, I think this flushing rate is dominated by the fact that the water is just going out. And it's not, the fact that it's fresher would create a circulation itself. So even if there was no tide, if it was fresher, it would try to spread out into the Mystic River, but that's a kind of slow process. In this case, in all of these little coves like this around the state, when the water depth is comparable to the tidal amplitude, right? It's dominated by the mass exchange. This like this thing of it is a slug of water is just moving out. It's mixing up with some stuff in Little Narragansett Bay, and what comes in is slightly different from what went out. And so this persistent like transport, some mixing, then transport back in of something that's saltier is a mechanism. It's not like it's driving like an estuary circulation like you would see in other parts of the textbooks.
So something that you said caught my attention. I want to make sure I heard it right. You were saying, I think, that the silt is another matter entirely than like the salinity.
Yeah.
And I just don't know enough about this, and maybe there's a biologist here somewhere on the Zoom who knows about oysters, but I heard from one of our oyster farmers that they don't like to be in the mud. They like something that they can get a purchase on, like a rock or something. Does anybody know anything about that? So could, for example, the silt be?
Oh, yeah, no, the silt is the reason there's no clams, no oysters, no nothing on the bottom.
They can only filter silt.
Yeah,
Yeah,
the silt,
and horseshoe crabs don't like silt either.
yeah.
So the silt, so the causeway could be causing the silt to precipitate out at a higher rate than say
So if-
something that's more dissolvable, like saline.
I don't think that, if you go on the other side of the bridge and you dig into the mud, it's the same black mud
It is?
on the other
Now?
side,
Wow.
Elihu Island. In fact, at Elihu Island, it's actually deeper and nastier.
Mm.
So this pervades the whole of Little Narragansett Bay.
Yeah.
So that you would just be, even if you could export the silt, you'd be bringing back the same thing if it's suspended in the water. The way to get the silt out is to get the oxygen up. The way to get the oxygen up is to get the nutrients down. The way to get the nutrients down is,
You may be talking about different sources of silt and what because on the
they're organic.
on the
silt.
base side, it's more organic material that comes in in some of the to get
The cladophyra.
right
Yeah, and
And on
it's
the
same with
inside-
you as well. Yeah, inside as well, right?
inside as well.
There's cladophyra mats, right, inside as well. And the added, leaf litter, like the normal stuff from the land, but definitely there's cladophyra on both sides. And they end up making this organic matter, which typically, if you don't have too much of it, it'll decompose and you're gonna be left with your sandy substrate. But when there's not enough oxygen to burn off the organic material,
It's blocking sunlight too.
So one thing that it could be important is that waves resuspend sediment close to shore. And the bridge blocks pretty much all the waves coming into Wequetequock Cove. But if there's stuff collecting on the south side of that railway bridge, then so it's basically salt is dissolved, so it goes with the water precisely. The sediment sinks a little bit, so when it gets to slack water, some silt will fall towards the bottom, and so it tends to collect because it's not going to go out when the water. So you could bring silt in, it settles to the bottom, and then 3 hours later it goes back out. And how long it takes to settle from the surface to the bottom depends upon the particle size. But if you got some fairly big particles, like even a clay particle, will settle like a meter maybe in 6 hours or 12 hours. So you could collect some stuff just due to that mechanism. It's like bring stuff in and settles, but I don't think I can say much. I can provide any actionable advice on that without more work. But you know, I think this effort was not very much work for me, so it was easy to do. But I think more deeper questions or more work.
So Jim, from what it sounds like, we've been relying a lot on push data taken twice a month, 2 weeks. But it sounds like to really sort of target in and understand more precisely, we could stand to have a lot more data points.
Yeah, so I think those kinds of data are useful for classifying problems. So if you take a sample once every 2 weeks and you see it's low DO sometimes, you know there's low DO, right? But if you're going to take action and you want to spend people's money and your own money, like on doing stuff, I think you need to know more mechanistically what's likely to happen. And so for that, I think you need a better designed, a precise, a targeted study, right? Rather than a sort of a survey.
I think we're finding that to be true, because the Cush data goes back so long to 2008 that you can see things are generally true in it, because the same things happen over and over again in the same places. And you know, so you can count on the bacteria being higher at one certain measurement point just consistently than another, right? So I think we know they're generally true, but we're finding out that other things like, well, where is this bacteria coming from? Is it from the septics, right? And therefore, is it human or animals like the geese or something else?
Yeah, that's exactly my point, right? From a survey perspective, it's valuable, but from an action perspective, it might not be adequate.
So definitely several different areas along the cove, multiple times a day would be ideal.
It depends what you're trying to do. Right?
Yeah, so I was gonna go there. What are we trying to do? I think, to me, it's pretty clear that the land use around the cove is problematic. Like, you know, the septics and the fertilizer and all that gets brought in. So we could commandeer more surveys, but to what end? Like, the important part is convincing the town to spend money to extend infrastructure. And I don't know how we get to that point. So we could chase our tails and collect 10 years more data, right? Get really high resolution data, whatever, but what does the town need in order to invest in Wequetequock?
Well, are you not violating the water quality standards right now?
I think so.
I mean, I think if there's forget the law, right? But there's my understanding is that there's like a law that requires the state and the towns to take action when the water quality standards are violated, right? And by that, look dissolved oxygen. Now, what the standards are depends upon where you are to some extent, and it may, because in well-functioning marshes, it may, you know, the oxygen goes to zero.
So I think the town wants proof that it's people's failing
Yeah.
septics.
And there are multiple ways we could get at this too, because I mean, we heard last time when the director was here and I talked to him afterwards a little bit more, and what they're talking about is getting ready for a strategic plan in the next 2 years, having a strategic plan done in the next 3, which would then go to the priorities, which, you know, if they then proceeded immediately, it's like another 5 years, right? Whereas a septic replacement of a failing cesspool could be done in a month, right? And probably the biggest barrier there would be, you know, 20 grand in funding for that, right? As opposed to millions. And so, and if we got really aggressive on the septic, we might push to get nitrogen removing stuff, get a waiver from Connecticut, because Connecticut currently does not allow those.
Is there possible grant money for residents to offset installing?
That's what I'd like to know, and I think that there are folks that are much more knowledgeable in grants and where those might come under. But I feel like I've heard from Dan that it's not
sounds-
unrealistic, and Darcy once said too, that she had success in a whole different place. Like
Yeah, I
Florida.
think we were, there was I forget, 493 or whatever, they're not huge, they're 500,000, and we considered it, but we're data limited because we didn't know whose septics to replace, for what reason. So in writing a proposal, you have to have a plan of action, so in the short time that we had on Zoom, it's like, okay, well, we don't know who has these failing septics, and how do we prove that, and whatever, right?
Well, one thing you could do, I think, is, and so harmonizes with our initiatives at this state, is to try and develop a program not to fix them, but to incentivize people to cost share. And in that case, you can create a program that would be funded, that would provide like a 25% of the cost, or some reduced interest rate, for a fixed amount of time.
Suffolk County and Long Island, where they're really trying to clean up, is it Gardner's Bay there or whatever? They're giving 50% of the cost to homeowners.
Yeah, so Great South Bay
county
is the same,
Or like a tax incentive like you get for solar type of thing.
yeah.
Right, could be something
Yeah.
like that.
So that, and there's funding that available through several programs, I think, for doing this, but I think if you were to, there's always a cost share, right, with these things. So often if your town applies, for the futures fund, for example, it's at 50% cost share. So you get $1 million.
Pretty good idea where some cesspools are. I think knowing that though, I think that some of those properties in question, there's hardship cases. And so, but if you're talking about, what if there are just 5 cesspools on the cove that are contributing 80% of this, right? And you're talking about, a modern, like bunked system, you're probably talking 20 grand a piece.
Yeah.
So you're talking about finding a way to raise 100 grand. It's not crazy. If all those were hardships.
Well, relative to building a sewer system, extending sewers or changing a railway bridge, right? Those are $40 million things.
And if any of them are veterans, you would wonder if there are some veterans programs out there that might help a veteran having a hardship. There seem to be sometimes a lot of those programs.
Yeah.
So I think the case would be strong if you could show that it was nitrogen from a septic field, it was a problem. And for that, I think like a sampling program that was designed to determine whether or not that's true.
Yeah.
But that's something that could get funded too.
Julie, do we have data on nitrogen?
Oh, we have tons from Kush.
On nitrogen?
Yeah. It's not clear who's nitrogen, right? Where did it
So
come
then
from?
the next step would be to test further to understand what that.
Well, I think that the most direct is the bacteria, and to the fecal bacteria, right, in the water, and to do assays to see that it's human bacteria. And then it becomes more difficult for people to argue, well, it's not
Yeah,
the
it's
town
not-
residents if it's human, and that's within reach, right? That's easy to get money for that. It's not very expensive, and there's even people. I think Mike Whitney has a thing now that he bought that does this type of analysis on sugar.
Whitney's analyzing bacteria.
I know, right? But I don't know. Weird enough, but yeah, so that could be done. What I wish is that the town would take interest so that we didn't have to do this on a volunteer basis, right? That they have people on payroll that can apply for grants, that can query citizens for, do the research on who has failing septics as opposed to us on our free time on the weekends. But I wonder how do you get the town to move on that? And maybe it is to prove that it's human bacteria in the cove, and then that you're violating certain clean water laws, right?
I can ask my daughter, she's a marine science graduate. I don't know if you know her.
No, isn't it?
Tiffany Rich.
Well,
Of course, we know Tiffany.
Yeah, okay. So anyway, so Tiffany's last job, when she was in upstate New York, she ended up working for a water company, testing company, and they got a samples a couple times a day out of Saratoga Lake
Hmm.
to check if people were allowed to be swimming in there. I mean, our state tests all our lakes all the time, so I don't know why.
yeah, so, but
I don't know why you couldn't have tapped into, I mean, because, I mean, she was at Millstone, she tested
And that's
water
right.
every day.
And that's right, I remember her, she was there.
Yeah.
But those bacteria counts are not isolating whether a human.
Well, no, but I mean, she specifically at Millstone was looking for something else,
Oh.
but when she was up in Saratoga,
Oh,
it
they were
was
looking for human?
it was definitely for water quality and safety. And
No, here too. I mean, they won't let you swim.
Right.
but they could argue, well, you don't know if it's a goose who did it or human. So figuring out if it's a goose or human, that's a little more involved, but there's ways.
Yeah.
It's just, I mean, it's just people's time, and the pro bono thing only goes so far, so.
Mhm.
So, yeah.
Doesn't like, health, monitor. Septic in that.
So for you folks
Is there a
remote,
mechanism by which
yeah,
septics and cesspools?
so
Yes.
folks at remote, Steve McCabe is asking whether Ledgelight monitors. And no, they do not. They only act on reports. So if someone makes a complaint of a failing septic, they will investigate. And if it's then proven to be failing, they will make that homeowner remediate. But absent that, no. And it has to be actually, failing.
So there's no mechanism in place in County to determine if septics are failing discharging.
Zero.
It needs to be legislation. There's that. Andre was on earlier, but
Oh, he was? Okay.
Yeah, it does it.
yeah, actually, a couple of years ago, you can't even tell if a well was tested and had stuff in it, if you're buying a home. Like if you're buying a home and they had their well tested, you can't get that information. It's against the law now. And that's
This-
crazy to me.
This whole thing, from my perspective, where I got active on this is when I went to sell my house at 945 Stonington Road. And it failed the water test in the well because of fecal bacteria, too numerous to count. And it's not unusual. So you shock your well because usually something died and fell in it. And I shocked it 10 times and nothing changed. So it took installing a ultraviolet system to kill the bacteria to remediate the situation.
Hello,
Hello.
still have that.
Sorry?
He is talking, you just can't
Oh,
hear. Oh, Dan Mullins, yeah.
No, that's us.
Maybe, all right, so anyhow,
Well, we could still, if people, somehow we figured out how to get people's water for the Wequetequock Cove Festival, if I knew in advance, I could organize. So that we could test the bacteria count in their water fairly easily.
I think one of the things that we're learning stuff and getting to some challenges to some theories like the flushing, it's good. But the one thing we circle around all the time, and I think we now need to just come together as a group and just put an end to it, which is like, okay, we suspect, just like we suspected that flushing was a problem versus other places, maybe it's not. We suspect that septics and cesspools are contributing. So I think it's time to do water sampling in the cove and prove, and maybe in some wells that are turning up fecal coliform, and say, what's the source? So how do you do that? Like, how would one go about testing And what would be a rough order of magnitude cost of that? So we might then either crowdsource or apply for funding.
Well, I mean, if it's in-house, then it's just the fecal bacteria counts, that's cheap. The tracking, the DNA stuff.
Yeah.
It can be $600 a sample. That I've seen.
Okay, but you're not talking 10,000.
No. Right, but
How
then
many
there's,
samples would you need to have a credible?
that is the real question, and that I'm not certain.
Yeah.
Like, what does
Well,
it take?
how
what
many
does
would it take to then have what we think of as a lead maybe versus proof? Like,
Like a sample. of
yeah, we, you know,
Yeah, like
we-
5 is a lead, right? Proof to convince the town.
so 5 tests might be a lead to say if, and.
After a rainstorm, so we hit the jackpot.
Yeah.
Okay, and so,
Great rainstorm.
and when you do this, you said it's genetic, it's DNA testing to find out the source of it. Do those assays allow you to test for multiple sources, or do you have to say, I'm just looking for human?
Yeah, you have to tell them which source, and each source is a test, so each source is $600.
But you could do that with the same sample. and
Yeah,
each sort-
yeah, you
but
could say,
it's
I
the
wanna know
process
if
by
it's a
source.
human, a goose, a horse. You know,
So I think let me, do people generally feel like this is something it's now time to dive deeper and see what the source of the bacteria is, Carol?
I think it is, but, I'm just thinking up. So you go to a spot in the cold, you take a sample and it shows you the coliform. How do you know where it came from?
That's what we're talking about, is now
well, you know who
testing
it came from.
to say,
His house is all over the place.
Oh, yeah, that you don't.
oh, well,
So-
we're talking at least getting to the question of like what it came from. Is it a human being? Is it a goose? Right?
Dog.
And then we could begin to follow those leads.
I mean, I think all you need to begin to prove is that it's a problem, right?
Yeah,
I mean, that's where you, right, if you prove that it's fecal from humans.
I mean, what would be satisfying is if someone went out every time there was a rainstorm for a little while, like a couple months. And we tested all those samples and every time we got hits every time we got a human sample. So then it's like a recurring problem. Yeah, every time it rains, you flush the land and there's human fecal bacteria in the water. And then that would
Even during
convince me.
dry times too, yeah.
Yeah, even dry times, it's just the hits tends to be bigger when you just rinsed the land.
And all the outfalls.
Yeah,
Yeah, the
Yeah.
main low spots where
It-
runoff happens.
and I do think, Carol, there are ways that we could deduct our way towards it, and it's not gonna be perfect, but you can look on the town GIS and you can see all the properties. And you could start with some just general targeting and leads. So for example, if you're on a proper RC 123 acre lot, there's a really good chance your septic is, you're far away and you're filtering through a lot before it gets to the cove. If you're on,
20 or 40.
a 20,000 or less square foot lot, some of them are 11, 10, 5, right? And you have wastewater treatment and well on that same property. That's a good candidate to take a look. And again, I don't want to say things that might harm my neighbors. And so it needs to be done on a personal level, but I can think of a few, where you're talking like less than a 5,000 square foot lot on the water.
but I wish that the
With-
town
with-
did this work.
I would bet my paycheck is assessed.
But I wish instead of our free time to look at maps, identify, contact people, that the town took enough of an interest that they did this. Is that even in the realm of reality for the town of Stonington or?
Maybe we
Well,
don't
we can
provide
go
the
by the
data
behavior
first
we've
and
seen
then-
so far, and I think that they're genuinely interested and concerned But not leaning in to take action, waiting for proof and data. And I think the other thing we have to contend with here is our form of government. And our form of government, you know, it's largely done by boards and commissions and committees. And so it is incredibly fragmented. And you know, maybe the most important one to us, the wastewater commission.
Or aren't they most concerned with the operation of the publicly owned treatment works?
They are in a really bad position because no one would today design a system for a town the size of Stonington with 3 separate treatment plants that, you know, only 2 of which are interconnected and on and on and on. So they are, yeah. Their ratepayers do not cover all their costs, as you heard the last time the director was here. So, yeah,
It's not even that expensive when you get your bill.
well, yeah, because they don't charge what it costs to run it.
Oh,
So,
that I don't understand.
yes, but so either way, we gotta find a place where we can get a thread and pull it. And it does seem that the one thing we come back to continuously is, if Angula Brook established 2 probable causes. Well, let me start before that. I mean, I think what we're getting is reconfirmation that likely it's inflows of contaminants that are most likely suspect for the problems that are against our goals: clean drinking water, non-recreation, lack of habitat. We think that it's inflows, and those inflows, Angula Brook said, are likely from runoff and failing septics and cesspools. But they never tested to find out where. So I think it's time to, let's do it. So what I would propose is, I don't think we've had a data work stream in a while. This is probably the best topic for the data work stream. I'll circulate with Heather's help, like a query, who wants to join the data work stream. And I think most importantly, we need knowledge. We need your skills if you can make it. You've been so generous with your time, Julie. But we just need guidance, like how do we set up a testing regimen to begin to determine what, you know, what entity or entities are, like what beings are contributing this nitrogen. You know, is it on lawn? Is it lawn fertilizer? Is it animal? What type of animal? And then we can start to really search for where that's coming from. Does that make sense? And is that worthwhile?
I don't think any town wants to know that they have got human waste in their water. That you would think that would set off alarm bells.
So I think that there's hope that it will. I think that things in Flint and Jackson have begun to change the concept of liability around these. That you know, you can't just say, boy, it wasn't my fault, in benign neglect. So, but I don't think that that's really landed here yet, would be the way I've seen it reacted to.
You know, twice in the last maybe 2 days or 3 days in the newspaper, in the day, they've had an article about Stonington's been given, Stonington and Old Mystic, they've both been given some kind of historic register notation or something like this. Really a big deal, right? And they've got Wequetequock Cove, that's the only app in the whole coast. The other newspaper article, maybe yesterday, was about the state putting a lot of money to market oyster farmers all through, up and down the coast.
Big news.
Wequetequock Cove is an F. Blackmail doesn't always work, but pointing out to the town that how can you, you know, wave a flag and you want visitors, and money from the state and all that stuff. And get David Collins to come and write it.
Oh,
There you go.
I was just gonna say.
Talk about a mad dog, you know, get him on it.
Or Dr. Gotti.
Just to raise the visibility. of the problem.
Your favorite.
I do think you're absolutely right, and with previous articles that really began to get some people to come to the table. I think we need to do both.
Oh, yeah.
I think if we were able to provide some data that would take it to the next level on the sources, because all the previous articles had access to Anguilla Brook and the Cush data. And I think we probably benefit from some new. So,
I don't think they want to hear you if we say we don't like the way our water looks. But if you say to them, our water has stuff in it dangerous to people, that's a whole different story.
I agree with you, and I want that to be true. The dominant posture has been, if it's a well, it's not our problem, it's your responsibility. So, and I think that again, historically has been, an argument that goes unchallenged. I do think the world is changing a bit where you can't, not deliver services to an area and then blame the people there for having, polluted wells. So, but I think there's some work to do still. So this was fantastic, and I think it's great that we're challenging some of our walking in hypothesis. If you have any further thoughts that just as you're thinking about it, and if anyone is processing this now and can help us with an email or something, say, okay, like, to further suss out what's causing this, like silt is a really good suspect for killing the clams or whatever. And please, you don't have to confine your contributions to just in this meeting. You can email me, you can email Heather, you can email Clay, and we'll work on it. So it's at 7:20 right now. I think normally we do report outs. I'm gonna suggest that we suspend that till the next one. So we mercifully let people.
Can I just say though, the festival, all of the permits got approved, so it is July 14th, Sunday. We'll be reaching out for people to come and table, so.
And then can you coordinate with me to like set up a data and meeting and we'll send it out to membership. And then see if we'll have a special data meeting focused on how do we set up a test regimen in the Cove to test for, Julie, give me the right words.
Well, you could say enterococcus, but then you could say, what they call it, fecal coliform tracking.
Fecal
Is that
coliform.
right? No, they call it,
It's not my skill set.
I know, it's like a little bit outside my skill set usually, fecal coliform.
Who could we ask? Like, who could help us state the question?
Well, Jamie
I might be able
Vaudrey.
to ask my daughter,
Okay, ask your daughter.
because I mean, that's
Contribute.
what she did.
Oh, okay, that's what it called. It's microbial source tracking. That's what it's called in scientific. Just remember.
Okay.
Yeah, Craig was working on that in Mystic River, wasn't he?
Yeah,
There
maybe.
was there was the high coliform in the Mystic River last summer that shut down a whole bunch of aquaculture beds. for a
Right,
couple-
that was a
couple-
crisis.
Couple of
for
months,
oyster
yeah.
farmers.
Yeah,
And
well, Jamie Vaudrey has all the get up to measure the abundance. But not the who done it, but she could help us with the sampling regimen. Like where to sample and how often, but she could advise us on that. I could just yank her away for half an hour
She's great.
to ask her. She's overcommitted.
I know.
I was emphasizing after rain events,
Mhm.
low tide,
Yeah, and,
Right.
yeah, low tide, that's a good one.
you want to do it persistently.
And then how to find money, and then how to find someone to sample and measure those reliably.
Yeah.
There's another grant, there's a couple grant opportunities that are coming.
Yeah, we could stick a student on there and then you pray that student is reliable once you. This matters.
I did a project though, they made us students all kinds of crazy things.
Yeah.
Yeah.
They don't have any, so.
Huh? Yeah,
You know,
it's like, we wanted it to right frequency, I think it has to.
Available.
Yeah, like
Almost
either
like-
someone retired and dedicated or graduate students.
Mhm.
Anyway, we can sort that out. It's just, but yeah, sources of funding would be good.
So, so we'll organize, that conversation on, we'll use our data work stream to do that. If we've made the time convenient for you, could you be
Oh, yeah, no,
a contributor there?
I'll comment.
So, and then our goal in that will be to try to, state the question and then figure out where we could get technical assistance to design the testing. Make sense? And then if, once we discover like where that bacteria is coming from, we can begin to, like, think where the suspects would be for that type of contributor.
Right?
All right,
Yeah.
Thank you, Jim.
Thank you.
Welcome.
Very
Oh,
interesting.
hey, next meeting is
Good to see you, Bob.
June 17th?
Yeah,
Good job.
Next meeting, June 17th. Thanks, everybody.
June 17th.